Hey, welcome back to this bootcamp series. In this video, we're going to learn about databases, or to be more specific, MongoDB. Now, so far in this series, we've learned about programming, we've learned about servers, but none of it has felt very real world, and this is because we haven't had any permanent place to store data or to load data from, right? So instead of storing data in a permanent place, we've just been logging it to the console. And instead of loading data from a permanent place, we've just been faking hard-coded JSON. So I think having a database to work with is going to change all of that for the better. I think this is where the things that you're coding and building can start to feel realistic or meaningful. One last thing before we jump into the action. This entire bootcamp series is sponsored by me. So as many of you know, Udemy every year runs a big sale towards the end of November, and as far as I'm aware, that sale hasn't actually started yet, but I've been getting emails and comments, people asking, do you know when the sale is going to start, or do you have any discounted coupon codes you can share? And the answer is yes, I do. So in the description for this video, there will be a link to each and every one of my Udemy courses at the lowest possible price, and those coupon links are good for the next 4 or 5 days. Okay, so that's just something to check out. Anyways, having said that, let's jump into the action. Let's learn about MongoDB. Okay, so we're going to be using MongoDB in this video, but before we really get started, I want to put that into context because there are many different database systems to choose from. So in this bootcamp series so far, we've been using Node.js for our server-side or back-end code. Now, Node is just one of many server-side languages we could have chosen. Instead of Node, we could have used PHP or Python or Ruby or any other language to handle our back-end code. The reason I chose Node for us in this bootcamp series is because we already need to learn JavaScript for client-side reasons, right? Front-end JavaScript. So I figured let's not use any more brain horsepower learning multiple languages. Because when you're just starting out, it takes a lot of brain horsepower just to understand how all the different puzzle pieces of development fit together. So I think it's a good idea to just use one language, JavaScript, for everything. However, down the road, once you're a bit familiar with the jobs and responsibilities of each piece of technology, then I think it's an excellent idea to learn a different server-side language, whatever you choose. Okay, and now everything I just said about server-side languages, this also holds true for database systems. So again, in this video, we're going to learn about MongoDB just because we can continue to use the JavaScript syntax. But in reality, once you're a bit comfortable with how all the different puzzle pieces of an app fit together, down the road, I would recommend you learn another database system like MySQL, or Postgres, or there's a bunch of others to choose from. And you can mix and match any of these back-end server-side languages with any of these database systems, right? Every server-side language has a driver that will allow it to work with basically any database system. So those are really subjective, personal, opinionated choices for you to make. I just want to be clear that the reason we're using Node and MongoDB is not because I think they're the, quote, best, but simply because they require the least amount of brain horsepower when you're just starting out, right? We can just use this one syntax of JavaScript and we don't have to have all these contextual shifts between different languages when we're really just trying to get a big picture understanding of how web apps work. Anyways, having said all of that, we are going to use MongoDB as our database system in this video, and we're also going to continue to use Node as our backend. I just didn't want to come across as super dogmatic about our tech choices. Okay, so how do we actually get started? Well, you absolutely can install a database system locally on your personal computer for development and educational situations. However, once you push your website or app live up onto the web, you'll also need a copy of your database to be hosted up on the web as well. So in order to keep things as simple as possible in this video, I'm going to recommend we just create a MongoDB database up in the cloud. That way it's online and hosted from the very start. Now, if you're a bit more experienced, you might want to look up a tutorial on YouTube about installing MongoDB on your computer so you can work locally. Absolutely, that's a great idea. But for everyone else, for most people, this cloud path is what I recommend when you're just starting out. Okay, this way we don't need to install anything on our computer, and when we're ready for our app to be live up on the web, our database is just already on the web. So to get started, it is completely free. Just go to the official MongoDB.com website, and we just want to sign up for a free account. So you can use the try free button or the start free. Just go ahead and sign up. So go ahead and fill out the registration form, and then on the next screen or a screen or two after this, it'll ask you to choose a path. There will be several different ways for you to, quote, create a cluster. So you just want to choose the option that is free. We don't need to spend any money right now when we're just trying to learn how to use MongoDB. At the time of this recording, the free option is on the right side of the screen, so you're looking for the Create a Cluster button that is free. After that, on the next screen, it'll ask you to choose a cloud provider. You can choose between AWS, Google Cloud, Microsoft Azure. I would just stick with the default AWS, and actually I would just use the default options for every setting on that screen, and then just at the bottom click Create Cluster. Okay? After that, you should be taken to a dashboard screen that looks something like this. Now, when you're very first creating a cluster, it is going to take somewhere between 1 to maybe 5 minutes. And you'll probably even see a message right about here that says, creating your cluster for the first time, please wait. So you can just go ahead and pause this video, and then once that actually finishes, now we can move forward together. Okay, so for our first real task, let's try to store a bit of data in the database. Well, actually first to do that, we need to create a database. So to do that, let's click on this collections button right here. Okay, now the very first time you go to this screen when your account is brand new, you're going to see this explore your data, and then it's going to ask you, do you want to load in a bit of example sample data, or do you just want to add your own? So let's click this add my own data. Okay, and then it's going to say, hey, you don't have any databases, you need to create a new database. So you can choose any name you want. I'll just choose maybe YouTube lesson. Okay, and then in MongoDB, when you create a database, you have to create a first collection. If you've ever worked with MySQL or another database system, you can think of a collection basically as a table, right? It's sort of the main top-level way to divide our data up into organized areas. So for example, on Twitter, there would be one collection called users with all the usernames and passwords, and then there would be another collection called tweets with all the tweets. Why don't we create a first collection and just call it pets? Okay, and let's go ahead and click create. Okay, cool. So we have our one database and it has one collection. If you wanted to create additional databases, you can do that. So imagine we were creating a pet adoption website. You'd have one collection for pets, one collection for users, so on and so forth. So a collection is just a way to organize or group your data. At this point, let's try to actually store a new item or a document or a piece of data in our pets collection. So if you click on pets, then on this right-hand side, obviously we have 0 results so far, but we do see this insert document button. So let's try that. Okay, so this is how you would create a new document or item in the collection. Now in MongoDB, we really just give it a JSON object, right? So we don't need to learn a new language or new syntax. This is just JavaScript. So let's imagine that each pet document or each pet item should have a name, a species, and an age. Let me zoom in a little bit. So let's give it a property of name, and then you can just hit tab, and let's set its name to meows a lot. Let's hit tab again. Let's give it a property of species, tab, let's say cat. Let's say age is 3. Okay, now you'll notice that by default, it already gave us this property of _ID. So the idea here is that MongoDB will automatically give each item a unique ID. Okay, let's go ahead and click insert. Cool, so now our pets collection now has one document or one item in it. It's the Meows-a-Lot cat. Now I won't bore you by adding additional documents right now, but you saw that you just insert a document and you give it a bit of JavaScript or JSON. So off camera right now, let me add a few more example sample pets. Okay, so now I have half a dozen pets, and some are dogs, some are cats. You get the idea. Now, sort of the whole point of a database is that you can look up just the data you're interested in. So imagine instead of 6 pets, there were 6 million or 6,000. And what if we only want to see the cats that are under the age of 3 or the dogs that are over the age of 4? Well, actually, really quick, before I show you how to find or look for certain data in the database, I do want to talk about the types of data we're storing. So if I hover over Meows a Lot, over on the right-hand side, I can click the pencil to edit that item, or I should say that document. And notice that the name is a string of text, the species is a string of text, but the age, we would want that to be a number instead of a string of text. So you can just click on this menu and choose, let's go with int 32. Click update. Cool, so that's just something to be aware of. Normally though, we're not going to be entering data manually like this through the MongoDB website. Normally, we're going to be adding data programmatically with JavaScript commands, and in that case, MongoDB can set the data type for properties automatically based on the type that a property is in JavaScript. At this point, let's learn how to look up or query specific data from the database. So up above our results, we have this filter bar, and let's just start typing in here. Let's give it a JavaScript object, and let's say we only want to see the cats in the database. So we really just sort of describe the types of objects that we want to return. So we'll say an object where species has a value of cat. So now if I click the find button, cool. So instead of all 6, that only returns 3 documents, the ones that are cats. You can change this to dog. Cool. Okay, what if we only want to see dogs that are a certain age? So we could say comma, have another property of age, and let's say only dogs that are 2 years old. Cool, so now we're just getting the 2 dogs instead of all 3 dogs. Now instead of looking for only a specific number, we could also say less than or greater than. So for example, imagine we want any dog where the age is greater than 4. Instead of just this simple value here, we can actually have another object, so another pair of curly brackets, and then just say $ greater than, or sorry, not greater than, just GT, colon, and then let's say 4. Push enter. Cool, so now it only returns the 1 dog where the age is greater than 4. You get the idea. Cool, so what else can you really do with a database? Well, really it all boils down to the CRUD acronym, C-R-U-D, which stands for Create, Read, Update, and Delete. Create is just when you add a new document into the database. Read is what we just performed, right? We queried the database for specific data. Update is simple enough, right? You can just click on, let me clear out the filter, find all my items again. Update would just be if you wanted to update a particular item, you could hover over it, click the pencil, make a change and save that change. That's an update. And then delete would be just clicking the trash icon on one of these documents. Okay, now at this point, we can perform all 4 of those CRUD actions very easily. And this is great. However, the visitors of our sites and apps, they don't have access to this MongoDB dashboard, right? Instead, they're just going to be visiting our Express server. So what we need now is a way to programmatically or remotely perform these CRUD actions on this database, right? We want to be able to perform those actions within our Node.js code. So right now, let's jump over to a text editor. I've already created a new empty folder on my desktop named MongoDB Node Test. So you can create a folder and follow along. Let's go ahead and start by installing a package. So in the command line, we can begin with npm init-y. So that's going to give us a package.json file. And let's begin by installing the official MongoDB package. This will allow Node to connect to a MongoDB database. So it's just npm install. The name of the package is aptly named. It's just MongoDB. Okay, cool. Now let's go ahead and create a file and try to connect to our database. So I'm just going to create a new file. You could name it anything, but I'll name it index.js, right? And so we're just going to write a little bit of Node code now. So let's go ahead and import or require in the MongoDB package. So const, you could name it whatever. I'm going to name it MongoDB equals, and then just require in MongoDB. Okay, and now we just want to connect to our database. So we can say MongoDB, and it has a method, so dot connect. Inside these parentheses, let's give it 2 arguments, so a comma b as placeholders. So this first argument is a connection string. So this tells MongoDB which database we want to connect to. And then also we can include a username and password so that it knows that it can trust us and actually let us connect. Then this second argument, we can give it a callback function. So this will run once the connection has actually been established because we don't know how long that's going to take. So let's actually start with this second argument here. Let's turn the b placeholder into a function. You could use an arrow function, but just to be as clear as possible, I'm going to actually spell out an anonymous function. So function, parentheses, curly brackets. Inside these parentheses, let's have 2 parameters, ERR for error and client. You could actually name these whatever you want. These are just sort of the industry standard names. The idea, though, is that inside the body of this function, we can use client to actually start working with our database. But let's not get ahead of ourselves. Before we can do anything with our database, we need to make sure that we give it a valid connection string. Right? Which database in the world are we trying to connect to, and do we have permission to even access it? Now, if you installed MongoDB locally on your personal computer, you would use some sort of local host value here. But in our case, since we used the MongoDB Atlas Cloud Service, we can look to them to give us a connection string value. So back in your MongoDB dashboard, in the left-hand sidebar, I want you to click on Database Access. Okay, so we have this tab called Database Users, and we just need to create a user. The idea is that this one cluster can have multiple databases, and maybe you want to create different users that only have access to a particular database. So let's just go ahead and create a new database user. We can use the default password authentication method. So just choose a username. Maybe I'll give it a username of YouTube lesson. Okay, then choose a password. I'm just going to use this auto-generate secure password option. Now, be sure to copy and paste this or store it somewhere so that you know what it is later. So I'm just going to copy that to my clipboard and then off in a separate text file somewhere or in a new tab in VS Code, just temporarily paste that in so you have a copy of it. Okay, and then let's scroll down. What kind of privileges do we want to give to this user? I'm just going to say read and write to any and all databases. Cool, and just scroll down, click Add User. So now we can use this database user and the password you just chose. We can use that within our connection string value here to actually get access to the database within Node. So check this out. If we go back to our dashboard and click on clusters, basically just go back and try to view our database. Instead of clicking collections to actually view our databases and collections, instead let's click this connect button. Cool. Now, before we ask for it to give us a connection string, we do want to allow sort of any IP address in the world. In the real world, you would only want to let maybe a specific server access your database, but because we're trying to access it from both our local computer, and I have no idea if you're going to use Heroku or Vultr or DigitalOcean, or maybe you're using Netlify, so it's going to be connecting from an AWS Lambda function. Since I have no idea what IP address you want to connect to your database from, what we can do for now is just click this Allow Access from Anywhere option. So that should be an IP address of 0.0.0.0/0. Right, just sort of a wildcard. Allow any and all IP addresses to connect to our database. So let's click this Add IP Address button. Cool, and now we are ready to actually get that connection string that we need. So we can click Choose a Connection Method. Let's use this Connect Your Application. Just make sure that your driver here is set to Node.js. And then this value here is what we're interested in. So just go ahead and copy that to your clipboard. Okay, back in VS Code. You could enter that directly right here, but what I like to do is just maybe create a variable, say const connection string equals quotes, and then paste in your clipboard. Okay, and then you can just point towards that for this first argument. Now we're almost done. You do need to put in your password for that database user. So you would also get rid of the less than right before the word password here and get rid of the greater than after password. So this part that I've highlighted actually include your specific password that you chose or that it generated for you. Once you do that, finally at the very end here, or at least towards the end, we see this less than database name, DB name greater than. You'd want to replace this with the specific database you're interested in. So in my case, close out of this and go to my collections. I named my database YouTube lesson. So that's what I'm going to put there. Right? I'm going to get rid of the less than and greater than and the DB name and just say YouTube lesson. Okay, and then again, also be sure to do the same thing, hollow out your password. I'm not going to show you my password, but actually instead, I'm going to show you the way that you would protect your connection string in real life. So the way that we've done it here will work. However, this would require you to have your private connection string and password living in your source code, meaning this is going to get pushed up to GitHub or Bitbucket. And what if you accidentally set your GitHub repo to public? Or what if somehow your repo or source code was leaked? Well, your entire database would have been compromised. It would be a nightmare. So it's a best practice to never have super sensitive information like this directly in your source code. So instead, I know this is a bit of a tangent. This doesn't have anything to do with MongoDB directly, but it is super important, so I want to show you this. Instead, in the project folder, let's create a new file, and we need to name it exactly this, .env. So we can store environment variables in this file. Let me show you how this works. So you just make up a name for a variable, and it's all uppercase. So you could choose anything. You could say pizza, but I'm going to say connection string. And then you don't even need a space. You just say equals. And then you don't even need to wrap the value in quotes. You just paste in the value. So that's actually what I'm going to do here, right? This connection string, you don't even need the quotes around it. Just the value that you copied and pasted from MongoDB. Just paste that here, right? Just like this, all uppercase, equals, no quotes. Okay, now off camera, I'll go ahead and put in my password here, but you do that as well. And then go ahead and save this file. Okay, now before we move forward, in order for this to actually be secure, sort of the whole point of this file, we would tell Git to ignore this file. So that way when you push your code up to GitHub or Bitbucket, your private data here is ignored. So just create a new file in your repo folder, call it .gitignore, and then just be sure to include .env. Hit save. So now when you turn this folder into a Git repo and you push it, your private environment variables will actually stay private. They will not be in source code. Okay, now how do we actually use this environment variable of connection string? Well, we just need to install a package. So in the command line, we just say npm install. Its name is .dot.env. Let's press enter. Now watch how easy this is. Back in our index.js file, we just, up on the very first line, let's import that package. So just const.env equals and then require it. And then right below that on a new line, just say .env and call its config method. That's it. So now, when we're actually trying to connect, when we want our connection string here, to access that environment variable, we just say process.env and then we named ours all uppercase connection string. Now, before we jump back to the actual topic at hand, which is MongoDB, one last note on the environment variables. This will work locally for us because we have the .env file on our hard drive. But you might be wondering, Brad, how is this going to work when I push my code up to Heroku or Netlify? Right? Because if this .env file is ignored, then how would Heroku or Netlify know my connection string? Well, that's a great question. So Heroku and Netlify are both different, but they have places in their dashboard for the particular project you're working on where you can set up environment variables. So for example, in Heroku, if you go into a project and then click on Settings, down just a little bit, you'll see this config vars, reveal config vars. And if you reveal that, you can set up key value pairs. So this would just be all uppercase connection string or whatever we named it, right? And then you just include the value here. This way, those ultra important secret password values, they don't exist in your source code, which could potentially get leaked. So that's Heroku. Netlify has something very similar, right? So for a particular project, you can just click on Site Settings. Okay, Okay, then down here, we're looking for this build and deploy area. And then if you scroll down, you have to scroll down pretty far, but you'll see environment variables. Cool. So I know that was a huge tangent, but that is sort of the best practice way to keep your private data ultra secure. Okay, let's get back to MongoDB. So the whole idea is now inside the body of this function, we can use client. This is the database client. This is how we can actually work with the database. So let's create a variable. You could name it anything. I'll name it DB and just say that it equals client. And then I'm going to call a method that it has called DB. Since we didn't provide an argument in these parentheses, it's just going to give me the database that you specified towards the end of your connection string. Cool. So now we have this variable of DB. We can start to do some really useful things with it. For starters, let's just try to retrieve any and all pets from the pets collection. So let's do this. Let's say db.collection. That's a method. And then you tell it which collection you're interested in. So let's say quotes pets, right? That's the collection we want. And then on that, we can call a method of find. Now, if you wanted to find just the cats or just the dogs, you could use that same query syntax we saw earlier that we used in the MongoDB website. But if we just want all of the pets in the collection, you can just leave this blank. Okay, now that's going to return data that makes sense to MongoDB, but doesn't really make sense to us as a human developer. So instead, what we want to do at the very end of this is call a method of .toArray, right? So that's just going to give us an array with basically JSON data. Cool. Now there's just one more detail we need to remember, and that is that we have no idea how long this database action is going to take to complete. It could take 10 milliseconds, or it could take 10 seconds. Who knows? So this is actually going to return a promise. Now there's a lot of different ways you could handle this, but what I'm going to do is just make sure that we're working inside an asynchronous function. So the nearest parent function right here, right before that, just add the word async. Okay, now at the start of this line, let's just store its results in a variable. So let's say maybe const results equals, and then right before this, since this is going to return a promise, just say await. Cool. So now the next line of code will actually wait for that to finish. So we can just say maybe console.log the results. Okay, so let's take this for a test drive. I'm going to save this file. Make sure your .env file was also saved. And we just jump into the command line and we just run this file, right? So it's node, and then the name of my file is index.js. Push enter. Cool. And there you see JSON data for the 6 pets in my pets collection. Now up above those actual results, you'll see this warning. It's just letting you know that in the newest version of MongoDB, or I should say in a future version, they're going to deprecate a certain feature. So if you want to make this warning go away, all you need to do is after this first argument of the connection string and in between the second argument, just add one more argument. So I'll add a comma here. And then the second argument is just a configuration object. So if you just say use unified topology, I have no idea if I pronounced that correctly or not, but just set it to true. And I'll be honest, I have no idea what this setting actually does. If you save that and then try your task again, so I'm gonna press Control-C to stop that task, and then to fire it up again, just node index.js. Cool, now you don't see that warning, you just see the 6 pets in the database. Let me press Control-C once again. Now the reason I'm having to press Control-C is because we didn't tell this task to stop, or actually I should say, we didn't tell it to disconnect from the database. So after we're done, we can say client.disconnect and call that method. Oops, sorry about that. It's actually not disconnect. The method name is close. So if we try this out again, cool, you can see you get the data and then the task gracefully actually finishes. Now, as we'll see towards the very end of this video, when you're actually working with an Express server, there's no need to manually close the database connection like this. Since your server is just listening for incoming requests to different URLs ongoing, you would just want to keep the database connection open. Right, but for this simple node task that has nothing to do with a server or Express, this is how you would manually close the connection. Okay, and if we only wanted to query for the dogs in our collection, inside the find parentheses, you could just give it an object and say where species, colon, cat, dog, or whatever you're looking for in particular, right? So if I save that and run the task again, cool, I just get the 3 dogs in the database. If you want to learn about more advanced MongoDB queries, I'll provide a link to their documentation in the description for this video. Anyways, let's get back to the CRUD acronym, right? Create, read, update, and delete. We want to be able to perform those actions programmatically from within Node here. So we just saw the R in CRUD, right? We successfully read a bit of data. Now let's try the C, right? We want to create a document in the pets collection from within Node here. So let me comment out this line and let's try to add maybe a new dog document to the pets collection. So you would just say DB, right? That's our database. And again, call its collection method. We want to work with the pets collection. If you were going to be working with this collection many times, you could create a variable that was just this, right? So you could say const pets equals this, and then down below you could just keep reusing that variable. Right, so then I could just say pets dot, and then the method to add or create one new document is insert one. Okay, in these parentheses, you just give it a JavaScript object. So curly brackets, let's say name should be always hungry. Species is a cat. Age is 4. Okay, now this is going to return a promise. So at the start of this, we could await that promise, right? So we want to wait until this action is complete, and then we could log a message to the console that says added new animal. Now in the real world, you would want to wrap this in a try-catch block so that if we did run into an error, we could handle it gracefully. But we've already seen try-catch earlier in this series. So for now, let's just test this out. I'm going to save this. In the command line, just run node index.js. Okay, we see added new animal. Now to really test this out, back in MongoDB, you can just refresh your pets collection or just click the green find button again. Cool, so we see that we now have 7 documents. And if I scroll down, there is that new always hungry cat. Or to really test it out, you could have just used your find method right within our node code. Okay, so in terms of CRUD, we've seen how to create an item, we've seen how to read data. Now let's try updating an existing item from within Node here. Let me clean up this code that we're not using anymore. Okay, so imagine we want to update an existing item. So for example, imagine that item that I just created, the always hungry cat document. Imagine I want to change its name to usually hungry. So back in our code, we could just use our pets variable, and it has a method of update one. So in the parentheses, we give it 2 arguments, a comma b as placeholders. The first argument is just us saying which document in the collection do we want to update. So you can use the same syntax here as you would use with the find method. So in other words, you could say, let's find the document where the name is always hungry. Or what I would recommend is let's do it based on the ID. So let's say, let's find the document that has this exact unique ID. Now your ID number is going to be different than mine, but the idea is I just want you to go into your MongoDB database and copy this string of characters for a hypothetical document that you want to update. All right, again, yours will be different than mine. Let me just grab this value though. Okay. So now back in our code, for this first argument, get rid of the A, let's have an object. So let's have a property of underscore ID, colon, and now instead of just having a string of text and pasting that in, we actually want to use a MongoDB tool. So let's say MongoDB for the package that we've already imported, and it has something inside it, so dot, called object ID, and parentheses to call that. And again, that's an uppercase for object, and then an uppercase I, but a lowercase d. Okay, now in these parentheses, you can have quotes and then just paste in your unique ID. Okay, so this first argument is us just saying which item we want to update. Now this second argument, instead of the placeholder b, just give it an object. And let's use the set operator. So that's $set. then colon, and then you give that an object. And now you can specify any of the properties that you want to update. So this way we're not overriding the entire document, because imagine, what if this document had maybe like 20 or 30 properties? We don't want to have to spell out the entire document again. We're just setting the exact couple of properties that we want to change. So I'm just going to change the name, and let's set it to usually hungry. Okay, at the very start of this line, I'll wait until it's actually finished, and then we could console.log updated document. Again, in the real world, you'd want to wrap this in a try-catch block, but let's test it out. So node index.js. Let's go check in MongoDB. So if I refresh my collection, click the find button, scroll down. Cool, so now it's usually hungry. And finally, let's practice deleting an item from within our node code. So I'm going to delete this usually hungry cat. Right? So I already know what its ID is. It's still in my clipboard. You could probably even guess the method name I'm going to use. So instead of update one, I'm going to use a method called delete one. This first argument can stay the same. That's the item I'm interested in. And then I can just get rid of the second argument. Okay, let me change the console.log to document deleted. Let's give this a try. Cool, document deleted back in MongoDB. If I click find or refresh, instead of 7 documents, it's back down to 6 once again. Okay, now that does wrap up all of the hands-on coding that I wanted to cover in this video. So now let's take a minute to put this into context. Because you might be thinking to yourself, okay, so I can perform these operations within a node file, but how would I actually connect the dots and connect to a database within an Express server? Well, in this bootcamp, I don't want to spoon feed everything 101%. So in earlier videos, we already learned how to set up an Express server. So I think it would be fun for you to sort of take what you've learned in this video and go plug it back into an Express app. Now, I will admit it can be a little bit tricky in terms of making sure you connect to the database first before listening on a port within Express, but then at the same time being able to reuse your database connection across multiple files. So if you get stuck and you're really confused trying to actually implement database actions within an Express app, I've set up this repo that you can take a look at. There will be a link to this in the description for the video, but it's just my GitHub account, and then it's Express MongoDB example. So a way that I'll typically set it up is this db.js file is what you actually launch first, right? So that's what you start up with Node, or if you were using Heroku, that's the file that you would initially launch. Inside that file, that's what's opening the connection to our database, but then you might want to split up your code into separate files. So I'm exporting the database client so that if I want to be able to perform a database action in any other file in my project, I can just import this db.js file and access it like that. Also though, within this function, once I've actually waited to connect to the database, only then am I importing the Express app and then telling it to begin listening. Okay, and then the other slight change, if we go back and look at the app.js, this file is just for Express related code. And you'll notice that at the bottom, instead of telling it to listen with app.listen, instead I'm just exporting the Express app. And that way the database file can tell the Express app to start listening once that database connection is up and running. So I encourage you to maybe look at these files for guidance and just try to set up a basic Express app, right? Where maybe you have a traditional HTML form, and then you can listen for a post request for when that form gets submitted. You can look at request.body and maybe have the user fill out different fields. And then you could create a JavaScript object using those values and then store it in a database. And you could also practice sanitizing and validating the data before letting it get into your database. So you could just use simple JavaScript if-else statements to make sure that the user input sort of at least vaguely matches what you want it to or would expect it to. Also, a quick note, if you're getting really creative and the gears are turning in your mind and you're like, I'm going to use this to set up user registration. I'm going to start storing usernames and passwords in a users collection in my database. Absolutely, go for it. However, I do want to have one quick public service announcement. Never, ever, ever store plain, simple text user passwords in your database, right? Because if for any reason, if the security of your database was compromised, you don't want to leak all of your users' passwords. So, and this is really extra credit because we're going to talk about this in the very next video, but if you want to start experimenting with usernames and passwords, be sure that you use an NPM package called bcrypt. So you can see I'm on the website for the official bcrypt package on NPM. And what this package does is it lets you hash someone's password. So you call bcrypt.hash, you give it the actual password that your user typed in, that they want to use as their password, but you would never want to store that actual plain text in your database. Right? And then a common value for salt rounds is 10, you give it a function, and then inside that function, you can access the hash that it generates. The idea with a hash is it's sort of a one-way street. There is no way to decrypt the hash value back to the plain text. An analogy I've heard is that it's like once you burn a piece of paper and there's just ashes, there's no way to turn those ashes back into the piece of paper. So then you could store that hash value in your database, and then when the user tries to log in the future, you can just use the bcrypt compare function, right? So you take the password that they're trying to log in with and you compare it to the hash that's in the database. And then this callback function will have result either being true or false if it's a match or not. Cool. Now, even if you do experiment and set up a registration form where users choose a username and password, you'll still get stuck and have no real way of remembering or trusting that user for subsequent requests. This is because we haven't learned about user authentication yet, but luckily that's exactly what we're going to cover in our very next video. One other super quick note before we talk about our next steps and where we go from here. I also have this gist that I've set up, and this is if you want to try connecting to your database from within a Netlify serverless function, right? An AWS Lambda function. So there will be a link to this in the description for the video. So you could use the contents here as a file in your Netlify functions folder. And this is an example of how you could connect to a database and then be sure to close the connection once you've got your data. Cool. That is going to bring the technical aspect of this video to a close. So where do we go next from here? Well, like I said, even if you did set up a registration form and a login form, and you made sure that the user typed in their correct username and password, well, that would be great, but as soon as they refreshed the page, for any subsequent requests, you would have no way for the server to remember them or trust them that they are who they say they are. This is because HTTP requests at their core are stateless. Now, luckily, there are ways for us to get around that and to have the server remember or trust you, and that's exactly what we're going to learn about in our next video. So we'll cover topics like cookies, local storage, sessions, JSON web tokens, and we'll kind of see their differences, their similarities, how they all work together to create something meaningful. I think it'll be a lot of fun. If you're enjoying this bootcamp series so far, as always, I'd appreciate it if you could share the link with your friends and family. Take care, and I'll see you in the next one.